Welcome to NASA Edge.
An inside and outside look at all things NASA.
You know, rollout has begun, Franklin. It's very exciting. The weather is good, a little windy.
Yes.
But you know, before we get into the details of what's going on with the GOES-S satellites, we had an opportunity, or Chris had an opportunity to sit down with Sandra Smalley from NASA headquarters to talk about the important partnership between NASA and NOAA, especially related to these two satellites. Let's check it out.
We're here with Sandra Smalley, the director of the Joint Agency Satellite Division. How you doing, Sandra?
I'm doing great. How are you today?
Pretty good. Now, as director, what is your role within the division?
Okay, so my division is within the Science Mission Directorate at NASA headquarters, and we bring to bear NASA's expertise in building spaceflight and ground systems, leveraging our expertise in science, engineering, program project management.
So looking at GOES-S, how does your directorate play a key role in the success of GOES-S?
So for GOES-S is the second in a series of geostationary satellites that we're building on behalf of NOAA. We build them, we test them, we launch them, and then we do the on-orbit checkout, and then we hand them over to NOAA for operations. GOES-S is particularly exciting because it's going to provide the second in this revolutionary series of satellites, which is upgraded the capability for our weather services and emergency response tremendously from the previous series.
Now, I like this partnership between NASA and NOAA. Does that start with your division?
So it is an interesting partnership. So when you look at actually designing new series of missions, that can take a couple of decades. When you start off with an initial concept, you're developing the new technologies, you're deciding what instruments need to be built for it, and then you start the whole acquisition and procurement process. So what NASA does is we oversee the procurement process in support of our partner organizations and meeting their objectives. We want to make sure that they have good estimates, for example, when you're designing and building a system, so that they can plan out their budget requirements and make sure that they're laying out the plans that are necessary to actually deliver these systems and operate them to meet the needs of their organization, actually the needs of all of us on a day-to-day basis.
What's the one cool part about the GOES-R satellite system that you take away?
Yeah, that is a really tough question to answer. I don't think there is just one cool part. There are so many cool parts about the entire system. I mean, everything from the advanced baseline imager giving you this amazing imagery where you can see the weather systems develop, the global lightning mapper where you can see the lightning as it develops within the storms, being able to see the whole solar instrumentation, see the solar flares, and understand the in situ type measurements so that we can understand what kind of radiation and all impacts might impact our spacecraft orbiting the Earth, as well as communication systems. It's across the board. I don't think I can pick one, but it's pretty impressive across the board.
You know, Franklin, it's amazing just to think about all the different technologies that are being employed in these satellites that are going to help with weather forecasting and emergency responding. But what's fascinating is through our partnership with NOAA, they're actually developing products from this data. They're actually the ones finding out how to take that data and put it in a usable form for those weather forecasters and emergency responders.
Yeah, Blair, and right now with the GOES-R and continue with GOES-S, there are over 30 products right now already available, and there are many more that are being developed that will be useful to people all over the world.
Yeah, and it's kind of like, I don't know if this is a good analogy or not, but it's kind of like they're creating like the weather data app store.
Absolutely. You know, someone can say, I need a solution to this problem, and when it comes to weather and prediction, they just might find it in the GOES-S satellite.
We had a chance, actually, to talk more about this technology with Ed Grigsby when Chris had a chance to sit down with him at NASA Goddard Space Flight Center. Let's check it out.
We're here with Ed Grigsby, who is the Deputy System Program Director for the GOES-R series. How you doing, Ed?
I'm doing excellent, thank you.
I was doing some research, and you have 4 key areas that I see for the GOES system. One, of course, being the visible imagery and infrared. Tell us a little bit about what you're going to be looking at with the satellites.
So you're very familiar with the GOES-R that launched in November of 16, turned into GO16, I think about 6 months after we launched it. That's our post-launch test period. You've seen the tremendous impact GO16 has. You watch the news every night, you see those pictures already in operations. So the ABI instrument, obviously from the previous GOES generation, 5 times faster, 4 times more resolution, and 3 times the spectral content, which means a whole host of products never before seen in the GOES series.
One of the things that really interested me, and I had a chance to interview Greg Mant from GOES-R when we did the show, and he was fascinated by this lightning mapping instrument. Tell us a little bit more about
GLM.
that.
Yeah, I heard something the other day that just astounded me. Since we launched and started viewing the Earth with GLM, we've counted over 13 billion strikes on the Earth. So just like that, GOES-17, GOES-S will launch and become 17. It will have a GLM identical, and it's going to view the east coast of Africa all the way to New Zealand, and Alaska will be able to see lightning strikes. And its tremendous potential is incredible. It sees in cloud and cloud to ground lightning, which is a real precursor to some of the most severe weather.
So the fact that you're able to see that lightning almost just as it's happening.
Right.
I mean, you can allow those forecasters and meteorologists to provide those early warnings much sooner than before.
Yes. There have been some projections, but it will be incredible.
But that's just on the looking at the Earth. But you have another half of the mission that's looking behind, looking at the sun.
We do.
Yeah. Tell us a little bit about that.
So we have several instruments that are on a solar pointing platform that look directly at the sun, SUVI. SUVI takes images of the sun, and we get to see in several wave bands what the suns look like, what the kind of mass ejections, what kind of heavy protons are coming with the SEIS instrument. There's EXIS, which is extreme UV. On the end of a boom, we have a magnetometer, which is providing some of the magnetospheric data that's required to really tell what kind of problems we may have with aviation or ground power.
All right, so I got to ask you this is an important question now, okay? So,
big important question.
As you said before, GO16, we're getting back a lot of great data, and we're seeing that. In fact, we had a chance to see that when we had the recent snowstorm on the East Coast. We were able to see the GO16 imagery, which was fascinating to see that in real time. What has been your most intriguing or interesting part about the GOES-R series? You got top 5?
I have a top 1.
Oh, there we go.
So when we were at the Cape and we launched GOES-R, I did say GOES-R series is going to save lives. And it does. For instance, during Hurricane Maria, when it hit landfall, the radar system went out. There was no data. There was no information that emergency managers could use to provide any type of emergency help. GO16 was there. During Hurricane Harvey, they used GO16 to actually track the eye of the storm. So there were 200 people trapped during that hurricane. They used the tracking from GO16 to actually tell the emergency managers when to go in and rescue those 200 people.
That is amazing.
Saves lives.
That's amazing. And now we're going to have the benefit of the West Coast getting that.
That's right.
That feature now.
That's right.
Especially with wildfires in California.
Oh, it's amazing. The amount of wildfires leave devastated areas that are prone to mudslides. So the amount of rainfall, the amount of precipitation, the view that GOES-17 will provide is going to increase their capabilities 100%. One thing that is incredibly important is that we found with our infrared imagery that we can see some of the early initiations of wildfires, even before the 911 calls come in.
That's amazing.
Yeah, it's incredible.
Hey, I'm joined here on the set by Mike Stringer from NOAA. Mike, tell me a little bit about the instruments on the GOES-S and how they will help to forecast the weather coming across the Pacific and how it'll impact the people on the West Coast.
Yeah, the instruments are going to help us see clear, faster images with more different spectrum. And putting that different spectrum together, they can see the moisture in the atmosphere. And so looking off of at the Pacific, they can watch these atmospheric rivers that come in that cause flooding in California. And so they can really watch that and see and be able to predict that better. As well as with the clear images, we'll be able to see things in Alaska. One of the things that we've noticed with GOES 16 is the ability to see ice flows in the Hudson. So now we'll be able to see ice flows up around Alaska. And then, of course, we'll be able to see the Hawaiian Islands really well and be able to get accurate predictions for them and typhoons and stuff that might be coming through that are going to affect their weather.
Tell me a little bit about fog detection and what that does for air traffic controllers and controlling flights in and up and down the West Coast.
So with our higher temporal resolution and the spectral resolution, we can see that fog, we can see it forming, and we can also see it dissipating. One of the things they did is in San Francisco, while 16 was in its checkout period, they were able to see the fog dissipating in earlier release aircraft that were being held, and it saved about $100,000 for the airlines in being able to get those aircraft going. So being able to see that vapor and watch it clearly is really helping the aviation folks.
Hey, Mike, thank you for being on with us today. We're looking for a successful rollout of the GOES S over at the pad. And right now, we're about to go to an interview I did with Pam Sullivan over at the Goddard Space Flight Center. She's going to talk about the instruments that they developed and put on the GOES S satellite. I'm here at the Goddard Space Flight Center today talking to Pam Sullivan, who's the GOES-R series flight project manager. Pam, how you doing?
I'm doing well. How are you?
Exactly what do you do as the flight project manager?
As a flight project manager, I'm responsible to build the satellites, and that includes the spacecraft, the instruments. I work with Kennedy Space Center to get them launched, and we also have the operations team that turns them on and gets everything working before we hand the satellite over to NOAA for operations.
But before you can build them, you have to know what you're going to be building, and you get that information from NOAA.
Yeah, NOAA, they do the forecasts, and so they collect all their scientists and they say, what observations do you need? And for example, for the GOES-R series, they said we need a lightning mapper, the first time they've had that operationally in space, so they asked us to design a lightning mapper. And for a camera, like the main camera that takes pictures of hurricanes and all the weather on Earth, they said that needs to go way faster and needs to have higher resolution and more spectral channels. It needs to see in more colors than we've had before. So they give us those requirements, and then the flight project is responsible to go out and get those instruments built for them.
Now, this is a big improvement over the last series of GOES satellites.
Huge improvement, yeah.
The instruments that are on the GOES-R series are the same over all 4 satellites, right?
All 4 of the satellites will carry the same instrument payload. The first one is a huge upgrade, but then it's it takes a while to get that into operation and for the forecasters to actually understand what all these new capabilities do for them and to fully be able to utilize that. They also have to tune all their tools. A lot of the software on the ground has to change as well because we've got so much more data and so many more capabilities. So it takes that whole process a couple of years to catch up as well.
Managing these satellites and getting them into orbit, tell me a little bit about the GOES-R S, the T and the U, how they're spaced out and how they're used.
So GOES-R we launched in November 2016. That was after a development period that really started in 1999, give or take. So a very long period of time to get to that first one launching in 2016. We checked that one out. We did about a 6-month on-orbit checkout, and then the scientists had another 6 months where they were understanding the products. And then just recently, in late 2017, that satellite got moved over to the East Coast, where it's currently in the GOES East doing operational forecasting right now.
Yes.
It's doing a great job, and everybody loves it. So much so that the West Coast guys feel like they're being dissed, so we need to get them GOES S. Once it's in place, we'll have full coverage between the East and the West satellite. We'll actually be able to see all the way from like the coast of Africa all the way across the Atlantic. Both satellites can see the CONUS, continental United States, and then the GOES West satellite can actually see all the way across the Pacific to New Zealand. So, we'll be able to see in the Atlantic, GOES East will see the hurricanes that really start off the coast of Africa and come across the Atlantic and can hit us there.
But GOES T?
GOES T.
Tell me about that.
So, so that is in development as well. We've actually got all the instruments built for that, and almost all of them have been delivered to the spacecraft out at Lockheed in Denver. And then GOES-T, we'll be getting ready to launch that in the middle of 2020. Assuming, the GOES East and West satellites are still okay, GOES-T will go up and it will actually become an on-orbit spare.
It'll just sit in orbit, just sit there.
It'll sit in orbit, yep.
Yep, and if need be, it could go east-west.
Yep.
Okay.
And then GOES-U is also being built because it's convenient. Once we've got the team together and they know how to build them, we'll just keep building them. GOES-U, we're not planning to launch until 2024, but it'll be built up and sitting in storage for a couple of years, and then in 2024 we'll get that one launched.
As the flight project manager for the GOES-R series of satellites, what is the big payoff that you look for after launch?
One of the most rewarding moments, very specific moment, was after we launched GOES-R and got it to geostationary orbit. There's the moment we call first light, and that's where you open the door. Typically, the instruments are looking at Earth, and it was taking its first picture of Earth. And for me, that it's more important than the launch, because that's when the satellite's working, it's doing its job, and the way the ABI works, you get like a swath of data, and it just came down, and you see the top of the Earth, and then you see the next piece and the next piece, and I was one of maybe a dozen people that was in the control room when that was happening, and everybody there knew that we were seeing, the dawn of a new age of forecasting. What this instrument was going to be able to do for forecasters, never been done before, and we were the first ones to see it in action.
Franklin, it has to be a very special moment for all these people that have worked on GOES-S, GOES-R, when things actually become operational and go live, if you will. We're here for the rollout today, and things are busy out at the pad. They're actually the rocket is making its way out to Space Launch Complex 41, and we're going to go talk to our friends Tiffany and Mick Woltman to find out what's happening with the Atlas V. Tiffany?
We are at Complex 41, and rollout is happening right now. It is right there, and what an impressive sight, Mike. Mick?
It is. This is impressive to see this Atlas V 541 here with the GOES-S satellite on top. I mean, I never get tired of this. This is a great shot that we're getting to see here. Tiffany, what I want to know is, this is your first time out for roll?
It's my first time being this close, and really have to thank ULA for allowing NASA Edge and us this access. I mean, this is phenomenal. My job is so cool right now.
Yeah, this is great just to see this thing rolling, and I'm hoping everybody's going to get to see this roll by here as we finish up.
So let's talk about rollout, Mick. Let's break down what is happening and where we are now with the rollout.
So rollout started about 10 a.m. this morning. ULA came in, the team came in and reconfigured the VIF to be able to make room for the mobile launch platform and get the thing ready. They hooked up the environmental control system and the P-van, which is the control van that feeds back to the Launch Control Center once they get that out here to Launch Complex 41. And yeah, they just great work, and they started right on time, and we're moving. It's about an 1,800-foot trip. It takes about 30 minutes. They're traveling about a half a mile an hour with this rocket, taking it very easy, but as you said earlier, it's an impressive sight to see this coming by right now.
This is amazing, people. Let's talk about the configuration of the 541. Break that down, what that means.
So yeah, GOES-S is using an Atlas V 541 configuration, and what that means in the vehicle is the 5 stands for the 5-meter fairing that encompasses the GOES-S satellite. The 4 is the 4 solid rocket boosters that we have on the first stage, and they give us just a little extra oomph to escape Earth's gravitational pull to get GOES into space. And then the 1 is the upper stage engine. It's a single engine Centaur. It's like the high performance race car that pushes GOES into orbit a little farther once we get into space. This is just, I'm sorry, this is just amazing to see this and hear this. It's awesome to be this close.
So right now people can see the tractor, the train part.
Yeah, you're looking at the mobile launch platform and the Atlas V sitting on top of that as it moves into Launch Complex 41 here at the pad.
And there she is.
Yeah, beautiful.
So let's talk about GOES LSP's history. We were there with GOES-L, and that was way back in the early 2000s, launched on an Atlas 2A. Fast forward, we got the GOES-S. It's on an Atlas 541. What's the difference with those two, and how was LSP part of both of those?
So Atlas V is a heritage design vehicle. It was built off of the Atlas 2A heritage that we launched, as you said, in 2000 with GOES-L. And back then, GOES was a little lighter. It was a smaller satellite, so we could launch that with an Atlas 2A. The lift capability needed was perfect. With GOES R series or the GOES S spacecraft today, that's a little heavier satellite, more telemetry, more things that can be done for weather. So we had to go with a bigger rocket, that lift capability to get it into space.
And I think she's in the shot. This is impressive.
Great.
Let's talk about LSP's history now. This is not history, our future. 2018 is a big year for us, and it starts off with GOES S. So let's break down the next missions that we have for the rest of this year.
Yeah, this year is an exciting year for Launch Services program here at Kennedy. It is our 20th anniversary. We started here in 1998 as a program, and 2018 is that culmination of 20 years. And we got 6 launches in 6 months using 6 different launch vehicle configurations. It's great. So GOES S is kicking that off. Our next mission is TESS, which is on a Falcon 9 in a couple weeks. Following that, we've got the InSight mission out of Vandenberg on an Atlas vehicle again. That's very important to us because it's an interplanetary mission off the West Coast. That's exciting.
Ours, yeah.
Then we go to ICON, which is launching on our Pegasus vehicle, that airdrop vehicle from the L1011. And then Parker Solar Probe on a Delta IV, another ULA vehicle, which is real exciting. It'll be the first satellite to get that close to the sun. And then finalizing out the year is ISAT-2. And for a lot of us, it's a heart puller there because it's the last Delta II. And they've been a workhorse for us at NASA. Atlas V is now taking that place into that workhorse family. So we're doing great.
Just a phenomenal year ahead, and we hope you join us for all of these missions. And with this, we want to wrap it up. Mick and I are go for launch. The vehicle is here. Back to you at the studio, Blair and Franklin.
Okay, all right, now Franklin, what are the odds that right after they cut back to us, they broke out a bottle of champagne and cracked it right there on the site?
We were praying to have that vehicle roll right through the shot during our live portion, and it did, and it looked great.
It did look great. And I tell you, one of the interesting things is being right there, I got to tell you, the jealousy factor way high here. I wish. How did Tiffany end up out there? We should have been out there with Mick. Pretty impressive spot, and obviously pretty impressive to see the rocket roll right into place. Well, I tell you what, Franklin, it's very interesting. That's going to wrap up our coverage, but the most important thing is, after what you've seen on the rollout, tomorrow you're going to want to tune in at 4:30 Eastern Standard Time on NASA television and watch the launch of GOES S on this beautiful Atlas V. Don't miss it. Tune in tomorrow. You're watching NASA Edge.
4, 3, 2, 1. And liftoff of the Atlas V and NOAA's GOES S.
Pressures are rolling off as expected.